Hey guys, we're just going to do a quick, simple review over exponentials as we prepare for our test. Okay? It should not be a hard test. Basically, if you paid attention and kind of understood the exponential stuff, this test should be easy. Alright? So problem number 1 says, describe how y equals negative 2 times 2 raised to the x relates to the parent function of f of x equal to 2 raised to the x. What's the only difference here? Oh, I brought in this negative 2. Well, this negative 2 is the same thing it's been in every other situation. The negative just means I reflect across the x-axis, so reflect across x-axis, okay? So, and then that 2 is bigger than 1. Remember, you ignore the negative. It's just the 2. It's bigger than 1, so it's just a vertical stretch by 2. Bam. There we go. All right, that's all that we need for number 1. Number 2 says, which of the following scenarios are modeled by the function y equals 1,000 times 1.055 raised to the x. This should look very familiar to a formula we talked about on Friday, which is y equals a times 1 plus r raised to the t, okay? So it looks like r is something like 0.055, okay? So r might be something like 0.055, so in percentage it might be 5.5%, okay? So a pond is 1,000 feet across, and each year its diameter grows by 1.055 feet. Is that a percentage growth, or is that just it grew by the same number each year? That's a grew by the same number each year, so it's not a percentage growth, so it's not exponential. This is exponential, okay? Exponential means I'm growing by some percentage each year, not just by some number each year. B, there is initially $1,000 invested in a bank account and increases in value 5.5% each year. That looks like it could be my answer, okay? Initially 1,000, that's your A, starts off at 1,000. We realize that R was 5.5%, which is what we have right here. All right, so let's read some of the others. There are 1,000 students in the club, and each year the club grows in size by 55 students. That's not a percentage growth. All right, D, the value of a red corn is initially $1,000 and increases in value 55%. Ooh, so that's pretty close. So let's go back and check our math. All right, so it's 1 plus R. This is 1.055. So R does equal 0.055. Is 55% the same thing as 0.055? No, that would be 5.5%. So that's why D is wrong. All right, D was very close. All right, number 3. Number 3, Sammy drops a ball from a height of 10 feet. Its height on each successive bounce is 2/5 of its height on its previous bounce. What is the exponential function best models its height on the nth bounce? Okay, remember, exponential means I have a number being raised to a variable power, okay? Is this guy being raised to a variable power? No, so that's wrong. Is this guy being raised to a variable power? No, that's wrong. These two guys are both being raised to a variable power. So now let's talk about the difference. This one says 10 times 2/5 raised to the n. This one says 2/5 times 10 raised to the n. So this one is saying I'm changing 2/5. So one time it's 2/5 to the first power, then it's 2/5 to the second power, then it's 2/5 to the third power. This one is doing that with 10. 10 to the first, 10 to the second, 10 to the third. Okay, so it says Sammy drops the ball from a height of 10 meters. So the height that he dropped it from is not changing. He dropped it from 10, and then each time after that, it's another 2/5 shorter. So what number does it seem like I'd be multiplying by each time? 2/5. So it's C, not D. All right, let's go look at problem number 4. Give a max and min value of fx equal 2 raised to the x over the interval of x from 2 to 8. Okay, we're going to let the calculator do this problem for us. Okay, so we're going to turn it on. We're going to go to y equals. We're going to type in 2 raised to the x. We're going to go to our table, second graph. And we're just going to look from 2 to 8. All right, so I can see 2. I want to see 8 at the same time. Boom. What's our minimum y value? 4. What's our maximum y value? 256. So min is 4. Max is 256. Awesome possum. All right. Number 5. Number 5 is probably the hardest problem on here. It says simplify. Okay, as I told you guys several times, the way I do this is I simplify the numerator, I simplify the denominator, Then I simplify them together. Alright, so when I look at the numerator, I see x to the third, x to the negative 2. I'm going to add those together and get x to the first. Okay? Y to the 8th, y to the negative 10th. When the bases are multiplying, I get to add the exponent, so that's going to be y to the negative 2. Okay? Z to the 4th, z to the 4th. When the bases are multiplying, you get to add the exponent, so that becomes z to the 8th. Alright? All over x squared, y to the negative 4th, z to the 9th. Alright, now here I would say I'm still not done simplifying my numerator because I have a negative exponent. I can't have that. So I'm going to take this y to the negative, what was that again? Y to the negative 2, and I have to bring that down. So on the top now, all I have is x z to the 8th divided by x squared. Remember, I haven't even looked at the denominator yet. I've done nothing to the denominator except write it out again. Okay? And I brought that z to the negative 2 down, so now it's not a z, sorry. I brought that y to the negative 2 down, so it becomes y squared down here. Okay? So now I'm going to look at the denominator. I'm going to see if there's anything I can put together. Let's see. So I'm just going to write the numerator again, x z to the 8th. Okay? Now when I look at the denominator, I see that I have no other x's, so I just write x cubed. I have a y to the negative 4 and y squared, so that's going to become y to the negative 2. And then I have z to the 9th. Alright? So to finish this, I need to take y to the negative 2 back up. So now I'm going to get a y squared. I'm just going to have to write over here. I'm just running out of space. X z to the 8th. And then I had to bring that y squared up. All divided by x cubed z to the 9th. X cubed z to the 9th. Alright? So now when I look at this problem, I think, okay, I've simplified the numerator, I've simplified the denominator. Now it's time to simplify both. X to the first over x cubed. So I get to subtract. So I would get x raised to the 1 minus 3. So that's x raised to the negative 2. But that would be a negative exponent on top, so instead I'll just put the x squared in the denominator to make it positive. Because originally this would go up top, because I did 1 minus 3, right? I did 1 minus 3, so since I did the numerator's power minus the denominator's power, it would go to the numerator. But that would be a negative exponent in the numerator, so I just went ahead and brought it down to the denominator to make it positive. Z to the 8th, z to the 9th, I'm going to end up with the same thing. 8 minus 9 is negative 1, so I'm going to go ahead and bring it down and make it positive 1, and then I'll just end up with a y squared on top. Bam, that would be my answer for that problem. Okay? Go ahead and take a moment, look over that. It was a hard problem. Let me know what questions you have. Okay? Problem number 6. State the y-intercept and whether it's increasing or decreasing. All right, the y-intercept is just this number right here. So the y-intercept is just 2/5. The point, 0, 2/5. And then if it's increasing or decreasing, you should look at this number right here that's being raised to your variable power. Is this bigger than 1? Yes. So therefore it is increasing. All right, problem number 7. Problem number 7, we're just going to use that formula we wrote out earlier. In fact, I'm not even going to write anything. I'm going to let the calculator do all of it for me. So I'm going to get 1,400 times, okay, this was 1 plus my rate of change, so 0.07, raised to, how many years did I leave it alone? 6. And I would have $2,101.02. So I'd have $2,101.02. All right, number 8. State the transformations. All right. So, let's see. There's been a... I'm going to type this out because that's just going to be better for me. Whoa, that is a huge type. Hold on. There's been a... This negative right here means it reflects across the x-axis. Okay. This 3 means there's a vertical stretch. Oh, I already said VS means vertical stretch. By 3. Alright. The minus 6 up here with the x means right 6. And then the plus 10 means up 10. Alright. Let's look at problem number 9. What is the domain and range of y equals 2 raised to the x? Okay. So the trick for this problem, for number 9, is to remember what the graph looks like. So you have yourself your xy plane, then remember that whenever you have an exponential function, you have an asymptote, and since there's no transformations on number 9, it's just the asymptote y equals 0. And then 2 is bigger than 1, so this is increasing. So it's going to go through the point 0, 1, and it's just going to look like this. So first off, it goes to left and right forever, so the domain is just all real numbers. Okay? And then the range, well, I just am basically from 0 on to infinity. But you'll notice I use parentheses on 0 because I never actually touch 0 because of the asymptote. Alright? Okay guys, I know that was a very, very fast video. Please let me know what questions you have. Alright, either through email or on Remind, or if you're watching during class, then just during class. Alright, thanks.